Okay, in Module 3, Lesson 6, we're going to be looking at doing a dilation on coordinate planes. So what we're going to be doing is we're going to be looking at coordinate planes. Now, in Lesson 5, we talked about the fundamental theorem of similarity and how to find the exact coordinate for the dilated points. Now today we're going to find the coordinates without that. We're going to look at the scale factor and the points. So if we look at this first example, we have dilated this here by if you look at the points, it was 3, 2, it became 6, 4. We took this line, it was 1, 2, and it's now 1, 2, 3, 4. So 2 times what is 4? That would be 2. So our scale factor here was 2. Okay. What happened to the points, the coordinates, to go from A to A prime? They were doubled. Okay. Let's look at another example down here. Again, same thing, fundamental theorem of similarity. Okay. We've dilated A and B along ray OA. Okay. A is here at 3, 3. A prime is up here at 4, or sorry, not 4, 4, at 12, 12. Okay, 12, 12. Okay, and just for the sake, when you see a coordinate, it's your x value first and then your y value. So you go horizontally, then you go vertically. Okay, so we went from 3, 3 to 12, 12. So what happened there? Can you determine the scale factor without counting? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went from 3 to 12. So to change those lines, we had to multiply by 4. Did that happen again with the coordinates? Did we take this and multiply it by 4 to get this? Yes, we did. Okay, so what we're going to be doing is we're going to be using the scale factor to find the new points. And all it is going to be is multiplication. So we're going to look at an example here, and I want you guys to follow along with me on these. So I would, if I were you, I would write them down. Okay, so example 1, A, so we have A, which is 7, 6, and I want to change it to A prime. So what I'm going to do is I'm going to have my original number multiplied by the scale factor, 11 over 7. And then I had a 6, and I'm going to multiply it by the scale factor, 11 over 7. Just like that. Okay? So A prime, now, when we multiply fractions, we could say this is over 1, and we can cancel these two out. So what we're left with as our x value is 11. Okay? And then here, we're going to have to multiply this because there's no way to simplify 6 and 7. So we take 6 times 11 and get 66, and 1 times 7 and get 7. Now, that's not very easy to put on a coordinate grid, but I'm going to show you how to convert this to a decimal. So A prime is 11, and then to do 66 over 7, the fraction bar is just a division bar. Okay, so you're going to take, let me move this up here, 66 and divide it by 7. We're going to round it to the nearest tenth, so that would be about 9.4. Okay, so all we're doing is taking our point and multiplying it by the scale factor. So this is doing it without the grid. Now we're going to look at example with the grid. Okay, so here we are. We're going to start with this, and we already have this coordinate. A is at -2, 3. And we're going to use the center. When we dilate, we always have to have a center. The center is O right here. And we're going to use a scale factor of 3. Okay? So I want to find A prime. B and B prime are already there, but I want to find A prime. So A is at 2, 3. Oh, sorry, -2, 3. So to find A prime, I'm going to take -2 times 3 and 3 times 3. I'm multiplying them by 3 because our scale factor is 3. Okay? So A prime would be located at -6, 9. So I would go over to my grid, I would go over to -6, and then I would go up to 9. A prime is at -6, 9. Okay? So now we're going to go to your packet and we're going to do some of this together real quick. This is just multiplication. We're just going to work through this together. Okay? That way you understand how to do this. Alright. So I'm going to change colors every time because I get bored. A is at 7, 9. So A prime, we're going to multiply by a scale factor of 6, would be 7 times 6 and 9 times 6. So A prime would be at, we just multiply, 7 times 6 is 42, 9 times 6 is 54. So it would be at 42, 54. That would be a very large coordinate grid. Okay? B is at -8, 5, and we're going to dilate it from the origin by the scale factor of 1/2. What's the new coordinate? So B is at -8, 5. So B prime will be at -8 times 1/2 and 5 times 1/2. Okay. So you can do this two ways. Okay. You can simplify if you remember how to do that. I'll show you how to do that in just a second, but I'm going to multiply first. So 1/2 is 0.5. So you can do -8 times 0.5 and get -4. Or you can say -8 divided by 2 gives you -4. So you get to multiply it by 1/2 or divide it by 2. Because that's simply what this is saying. 8 times 1 divided by 2. Okay? Or we can go in and we can do a little simplification. 2 goes into itself once, and 2 goes into 8 4 times. So B prime would be at -4. And then half of 5 would be 2.5, 2.5. So 5 times 0.5, 5 times 0.5, 2.5, okay? So this would be 2.5. Okay? C is dilated from the origin by a scale factor of 3/4. What's the point of C prime? So C is at 6, -2. C prime would be at 6 times 3/4 and -2 times 3/4. I always want to do that. Okay, so C prime 3/4 as a decimal is 0.75. So 6 times 0.75 is 4.5. And I'm just going to simplify this to 1. So this would be 3/2, -3/2. Or you could do it like this. 2 times, or sorry, -2 times 0.75, -1.5, which is the same as -3/2. Okay? D is at a 0, 11. Dilate it from the origin by scale factor of 4. So D is at 0, 11. D prime would be 0 times 4 and 11 times 4. So D prime would be at 0, 44. E, same thing here with a scale factor of 3/2, is at -2, -5. We're going to change it to E prime. -2 times the scale factor of 3/2, -5 times the scale factor of 3/2. Okay, so E prime, these cancel, and we get -3. And then this would be -15 over 2, 5 times 3 over 2. So if you wanted to do that and simplify that, it would be -3, and then you would do 15 negative divided by 2, -7.5. So that is how you find the coordinate of a new point once you dilate it. Now, you can use the multiplicative effect on a two-dimensional figure too. So this is just a point. Now we're going to look at a two-dimensional figure. Okay, so I'm going to do some more examples here. So we have triangle ABC, and here are our points. A is at 2, 3. B is at -3, 4, and C is at 5, 7, and our scale factor is 4. So what we're going to do is we're just going to take each point and multiply it by 4. Okay, so A is at 2, 3. A prime is going to be 2 times our scale factor of 4, and 3 times our scale factor of 4. So A prime is at 8, 12. B is at -3, 4. So to get B prime, we're going to take -3 times 4 and 4 times 4. So B prime would be at -12, 16. C is at 5, 7. So C prime would be at 5 times 4 and 7 times 4. So C prime would be 20, 28. And then because this is a two-dimensional figure, you would take each point and graph it and then connect the points. Okay? And then we're going to do another one. We have parallelogram ABCD, and we're going to use it by a scale factor of 1/2. So here we are. Okay, so we have our points, and we need to find the new points, the image. So A prime would be at -2 times 1/2 and 4 times 1/2. I didn't write them far enough apart. So A prime, half of -2 is -1. Half of 4 is 2. B so we take our coordinate and we're multiplying it by this scale factor, which is 1/2. So B prime would be at half of 4 is 2, and half of 4 is 2, would be at 2, 2. C to C prime would be at 2 times 1/2, and -1 times 1/2. So C prime would be half of 2 is 1, and half of -1 is -1/2. Or you could write this as a decimal. Either way will work. Just make sure you know what you're working with. D to D prime, -4 times 1/2, and -1 times 1/2. So d prime would be half of -4 is -2, and half of -1 is -1/2. And if you wrote that as a fraction or as a decimal, then again you would just take your coordinates and graph them and connect them in alphabetical order or in the order of the parallelogram. And we're going to do exercise 6 together in your packet, and then I'm going to let you guys do 7 and 8, and then you will show me what you got before you get to move on. Okay, so the coordinates for triangle ABC are shown on the coordinate plane below. Okay, it is dilated from the origin with a scale factor of 12. Identify the coordinates of the dilated triangle. So actually, I'm going to do 6 and 7 with you, and then you'll do 8 on your own because we're not drawing this one. Okay, so here we have A is at -2, 2, -2, 2. B is at -3, -3. And C is at 6, 1. So just like we did before, we're going to multiply all of them by our scale factor, and our scale factor up here is 12. Okay, so A is at -2, 2. So A prime would be -2 times 12, and 2 times 12. So A prime would be -24, sorry, and 24. B is at -3, -3. Okay, and we're going to multiply that by our scale factor. -3 times 12, -3 times 12. So B prime would be at -36, -36. Okay, and then let me screw this up. C is at 6, 1. C prime would be 6 times 12 and 1 times 12. So C prime would be 72, 12. And that's all you have to do. This one doesn't say graph it, it just says identify. So I have found the coordinate for A prime, B prime, and C prime. That's all we have to do on 6. On 7, now it says figure DEF G is shown in the coordinate plane. That's a quadrilateral, 4 sides quadrilateral. The figure is dilated at the origin by a scale factor of 2/3. Okay, scale factor is listed up here. We want to make sure we know that. Identify the coordinates of the dilated figure D prime, E prime, F prime, G prime. And then draw and label the figure D prime, E prime, F prime, G prime on the coordinate plane. Okay, so D is at -6, 3. And I'm going to write them down here, and then I'll go back up here. E is at -4, -3. F is at 5, -2. And G is at -3, 3. Okay, so what we're going to do here is we're just going to take these coordinates and we're going to multiply by our scale factor. And our scale factor up here was 2/3, and I will write it down here. Okay, so our scale factor is 2/3. So we're just going to multiply it out like we have in the previous problems. So D prime would be -6 times 2/3 and 3 times 2/3. So D prime. Okay, I know that 3 will go into itself once and 3 will go into itself twice. So -2 times 2 is -4. I know 3 will those 3's will cancel each other out, so we're only left with 2. Okay, so D prime would be at 4, 2. E, to get to E prime, you're going to take negative 4 times 2/3 and negative 3 times 2/3. Okay, so E prime. This one doesn't work out quite as easily. Okay, so we're just going to multiply. So if we put this over 1, 4 times 2 is negative 8 over 3. And then here the 3's cancel, so this would be negative 2. If we wanted to simplify that down to a decimal so we know where it goes, okay, 8 divided by 3 equals 2.7, negative 2.7, negative 2. I just take the numerator divided by the denominator. Okay. Looks like we're going to have to do that on F as well. Okay, so F prime is 5 times 2/3 and negative 2 times 2/3. So F prime, if we put it over 1, okay, and multiply, it would be 10 over 3. And then if we put, these two can't simplify, so I put it over 1, negative 4 over 3. So F prime would be at 10 divided by 3, 3.3, and 4 divided by 3, negative 1.3. Okay, and then we're going to do G. So G prime is negative 3 times 2/3 and 3 times 2/3. So G prime, okay, cancel and cancel would be at negative 2. Cancel and cancel would be at 2. So then, once we have our points, because it asks us to draw and label them, we're going to take our dilated points, D prime, E prime, F prime, and G prime, and we're going to graph them. Okay, so, use the pink. So at negative 4, 2 is D prime. At negative 2.7, negative 2 is E prime. And you're going to have to do a little bit of guesswork in there, and that's okay. Okay, as long as it's about in the same location, you should be good. F is at 3 1/3 and 1 1/3. And G prime is at negative 2, 2. And then once you have that, you would use a straight edge and you would connect your points. I don't have a straight edge right handy, but I'm just going to use the side of this. This is a straight edge. Sorry, I should say I don't have a ruler or compass handy, but this straight edge will work just fine for what I need to do. For what I need to do, which is just connect the dots. And that's what your dilated figure would look like with a scale factor of 2/3. Okay, and so you're going to go on and you're going to do 8 all by yourself. So you're going to have to first draw and label the triangle. You're going to dilate it with a scale factor of 1/3. You're going to determine the coordinates, and then you're going to draw and label it. So there's 4 parts to this question. Make sure that you do all of the parts.